What's up, everyone? You are tuned in to the Late Night Channel Eps. I'm your host, EEPMON, episode 72. And today, I thought I would do a little bit of a show and tell of one of my data artworks that I created. And it's based on the Typhoon Best Track Data of 2023. And this was being tracked by the Japan Meteorological Agency. Now, why did I do that? Well, first of all, I had to create some new artwork, and also because in preparation to returning to Japan back in February 2024, I had to prepare. I had to show some new artwork and the capabilities that I can do as a digital artist, not just digital and illustration, but also show my computer programming and coding skills. So sort of like showing what is capable and what's possible in the generative art space. So I thought I'd give you a little show and tell with that. Why don't we just go to the main stage? So here is the Japan Meteorological Agency's website. And I'm just going straight to it right now. And here, through this website here, this is really cool. It basically tracks all the data. I think, of course, we're going to do a best track data for 2024, but so far we only have 2023. And they have open source data of 2023 of the typhoon. And this is it. It is literally a .txt file, and it's a raw data file of all these numbers and all these digits, and you're like, okay, what does this all mean? Okay, but you can see that there's a pattern, there's consistency pattern here. And what I had to do, of course, there's a legend. So through the website here, the Japan Meteorological Agency provided some legends and information regarding the header data as well as the data lines. So it took me some time to figure it out, but this really helped me to really look at the data structure. So as you can see, there's like the header line has like five positions for A, 4 positions for B, C, D, etc. Right? And what they do is that these numbers correspond to 5 columns. Indicator 666 is probably just sort of like an identification number. 4 Bs is the international number ID. So yeah, so it's quite once you look at it, it makes sense. And then you can go to the data, and then you can just basically follow the like right here. This is the header line, and these are the I guess the body. Is that the body? That's the data lines. So I have header lines and data lines. So this is the data lines. Header line, data lines, header line, data line, and you just go through it. Now, with this TXT file, I use processing. Processing is an open source generative arts sort of application. You use code. So if I go to, here's processing right here. This is the program, and I have one screen, so I'm gonna have to like pull it up here. Ooh, there we go. Yeah, okay. And I don't know if you can see it. I've got Typhoon, and I have 2 files. The program I developed essentially is composed of 2 files. One I call Typhoon, that's like the main application, and then I have another a class structure called the RSMC best track data. So basically what it means that this, of course, I documented here, this class structure is responsible for reading the data, and not read the data, but basically taking the data, the raw TXT file, and break it down into its constituents. So the header lines, the data lines that I showed you before, and then really organize it and package it up in a way that I can use it programmatically and then prepare it for visual output. Now I'm sure my code could probably be a bit more streamlined, but I'm using a bunch of arrays of strings to hold the dates, and then you have an array of strings of the data lines, a string of store names. And I'm not gonna. I mean, for my listeners, I'm not sure if you guys are programmers or not, but I'll just kind of like just go through, just kind of show you sort of another side of what I do. And I love this. I love programming. I love merging art and code together because it's almost like that Venn diagram. I'm at my zen when I'm like programming. Sometimes I catch myself programming and I'm just like just doing stuff and not even thinking about like, whoa, I'm programming, which is kind of neat. It's kind of, I find it, very, very relaxing. So yeah, so here are all the, I'm just breaking it down. Essentially, this is called a constructor of the class. Every time you instantiate a class, it always calls the constructor, and the information or the text file comes in, and now I'm just breaking it up like crazy. Where am I here? Yeah, I'm just breaking it up like nuts. Set data lines. Oh man, so I'm using built-in functions in processing. One of it's called, this basically are like functions that handle breaking apart strings, like basically text or words. So I'm looking for specifically, from this part of this. Oh, how do I say this? At the first or if we find this first. How do I explain it easily? Is index of. It's more like a substring. Like extrapolate, 4 letters from this string, and then take that and save it out. So I'm just doing a lot of text manipulation basically, to really bring it break it down to its constituents, as I mentioned. And then this is the main application, where basically I am just essentially defining my colors. These are hexadecimal values. And now these Typhoon color grades are in fact, these colors are based on the Typhoon color standards, okay? So they're like, they're the tropical storm, there's different levels of them, and there's actually a international standard of what the colors are. So I'm basing those hexadecimal values based on that. Yeah, and then I can generate pie chart from all data lines. So I have these things called functions. They're just basically mini programs within my big program. And these mini programs do whatever, well, I have to program it, but it does the task, for example, generate pie chart from all data lines. It's a long ass function, but whatever. I like to describe some things sometimes. And yeah, sometimes I look at this like, I wrote this stuff. That's crazy, man. Using, who remembers trigonometry and sine, cos, tan, and all that kind of stuff. But basically, when I'm doing a pie chart, I'm like generating the circumference and calculating, because the circumference, like the full circle, right, 360 degrees is like 100%. So I'm really dividing it. I'm like splitting it in percentages, breaking the pie into different segments. But yeah, then I have my keyboard commands on it. Anyway, I thought I'd show you this because just a side again, like I mentioned, I don't show much about. But then let's play it. Here's a play button. Let's run this program. I have the data. I have the text file. As I mentioned, the text file is this flat file, which you can see right here. It's all that. Okay. This program will read this file, and then let's see how it executes. Now I'm gonna press the play button and see what shows up in here. Okay, so I just pressed it, but it doesn't show it. So let me see if I can bring it up. 1 second. Well, I couldn't show it at runtime, but I figured that I'd just show you on my website what it would generate. So essentially, this is what would have come out with. Based on the data lines and the header lines, it would create these outputs. So here's one of them, and this is based on central pressure. There's different things different measurements and different values that that I can output. For example, this is central pressure. Here's a close-up of central pressure. You can see again where, like I was mentioning, as it's drawing every arc, it's getting all the data throughout the entire year. And these triangles in the legend represents the highest point, like the all-time high of the entire year. That these were like the most how do I say, the most violent of the typhoons and whatnot. And these, where the blue dots represents the peak value of in the data line set. So yeah, so as I mentioned, remember there are header lines and there's data lines and then header lines and data lines. So the blue dots represents what are the peak values within the data line set. Now the triangles represents the all-time peak value of the entire year. So that's why you see, I don't know if you can see it, but on the upper left-hand corner, you can see that throughout the year, it's been somewhere around this part of the pie chart, which I believe you can get the date. If we look at that here, going closer, it looks like it was on August 17th. So this is based on data. So August 17th at 12 in the morning, August 17th at 6 a.m. So yeah, around August, I guess I would say that around August time is typhoon season is pretty much on the go. Here's another generated piece that I created. This is based on maximum sustained wind speeds. And again, so a different output based on different measurements. And that is why I had to really, in the code, I had to really break it down so that I could have more more data to play with, or more ranges, more outputs based on being more flexible with the code. So this is maximum sustained wind speeds, and then there are more outputs. This is longest radius of 50 kT winds or greater. And this is the shortest radius of 50 kT winds or greater. So it's just really neat to see data instead of on the spreadsheet, but visually, you know, isn't that so cool? It is like, it literally looks like a vortex. And what's neat about this is that this is real data. And I would say that when people or researchers can look at this, they can extrapolate perhaps more context behind the data than, again, like I mentioned, reading from a spreadsheet. This provides more value, I think, and more qualitative context to back up the quantifiable numbers and whatnot. But here, like, visually it looks great, but also it tells more of a compelling story is what I'm saying. Look at that. Woo, that's hard. Sometimes I look at this and like, oh man, I did that. While using computer code, of course. So the power of code. But yeah, look at that. I just love it. And again, a pie chart is one example. Like, there could be so many different outputs you can do. I'm just having fun with this. But you could do so much with just generating pie charts. That alone is such a, it's a beauty unto itself. So this is, I'm just having fun here. There's no mapping variance. This is just a perfect circle. So I thought it'd be kind of cool what that would look like. And based on that, because I had this prepared to go to Japan, I did provide and gave workshops when I was in Yokohama about data art. I gave presentations, workshops. People want to know how, wanted to know more about how I use art and creativity to, maybe the other way around, how I use data and express it in an artistic way. Neat. So yeah, I thought I'd give you a little show and tell with this kind of stuff. Let's go back to the code. Okay, here we go. Here. Yeah. Here, these are like essentially like global variables. I'm just like putting out. This is like a main application, okay? And then, of course, like in processing, there's always these pre-built functions that are required. Well, settings not really required. I'm just doing just because I felt like it. But setup is always needed. Setup is basically initialization. Initialize your variables at the get-go before the application starts. Well, setting actually goes first, but whatever. Setup is the most, like, you could do everything within the setup function. And then there's something called a draw function. And what the draw function does is, like, think about it as a program, right? You're running a program, but the program is basically continuously calling the draw loop, is calling draw all the time, like at like 30 frames per second. What's my frame rate on this thing? Actually, no, I don't have a frame rate because it's just a static. But think of it as the program is continuously calling the draw function. So if you can think about, imagine doing animation, or you want to like show this animation or moving things in different colors and all that. The draw loop will basically be responsible for updating the screen constantly, to refresh the screen, to reveal like updates based on variables, different colors, if that affects different colors, etc. But I keep it very simple here because, like, I have it all within the function. So here's an example. Like, I don't want to get too deep, but I just want to kind of show you a bit of a sample. So when a program runs for the first time, it does a setup, initialize the variables, and then it calls the draw function right away. Immediately, there's something called background 255. That means color the background of your app, like your screen or your window when you run the program, to 255, which is basically white, like white background. Give me a background white, and then there is this if statement. It says if save vector begin record. And basically what this begin record means is that whatever is being drawn on the screen, I want you to export that as a PDF file onto your computer. And that's only if the save vector Boolean variable is true. And how do I toggle that? Well, I have a key. I also programmed a keyboard input to toggle, like, press the T button to make it the save vector to true, and then do it. But right now, that's how it is. But if it's false, then it's not going to call the begin record. But calling the draw function, it will always call the generate pie chart from all data lines. Like I mentioned, the draw function always calls itself, so it's always calling this pie chart. So it's always drawing the data, like at whatever frames per second. So if we could just finish it again here. If save vector again is true, end record. You could also optionally want to save it as a PNG file, and then you exit the program. So really, the meat and bones of this application, or the meat of it, is called gen pie chart from data lines. So if we look at gen pie chart from data lines, it's right here, folks. This is the big boy. Is the big boy. So it calls in, and then you're basically, this is where I'm setting up my diameter, my last angle, all these ratios, a little bit of math going on here. Ratios, percentages, because I got to figure that out all out with the pie chart. And here again, oh wow, yeah, I'm doing a lot of like data manipulation here. So yeah, so I'm just basically taking all the information, the data, and just organizing it in a way that I could use it. Oh, this is a long ass function. Woo! Yeah, here, creating the arcs. I'm not gonna really describe it within the context of this episode, but I just kind of show you. I'm just having fun with this. This is a long function. I could probably break that even further into smaller pieces. Check for max level. Look at that. It's crazy, man. Ooh. This is the mark max point. Oh yeah, this is the mark max point. Basically, if this is an all-time high value, put a red dot on it. That's what this does. Here are my key press commands. So I'm just like, these are all the commands based on key input. So actually it's not. So yeah. So save vector is basically the R key. So I press R, it toggles save vectors true, save it out, and then it will export to a PDF file. Well, yeah, that's crazy, huh? Anyway, I thought I'd give you a show and tell. Yeah, that's it. Check it out. I'll put a link of my data art typhoon artwork in the show notes. Have a look at it, and yeah, if you enjoy what you see and you have any questions about art and code, leave a comment, and like and subscribe. This is the Late Night Channel Eeps, episode 72. Have a great evening, have a great afternoon, have a great morning wherever you are. If you, yeah, I'll probably like do more. If you guys are interested, I could do some little small programming tutorials or something in processing, because I love that program. It's a fantastic programming. I think programming is very important. Coding is important. I know that everyone's talking, well, you have AI, and the AI can generate all these code stuffs for you and whatnot. True. However, I think, at least for me, okay, from my perspective, as an artist, I can create, and it'll think, but I do, but coding is nice because it almost like creates a very rational side of me. It's like my abstract, artistic, crazy world meets rational, logical, like critical error side of me as well. It kind of combines these two together, and I think that critical thinking and that bridging between those two realms adds a lot of value at the end of the day, not just professionally, but also personally and creatively. So whether it's HTML, whether it's CSS, whether it's JavaScript, processing, C++, Java, Python, like any sort of programming, if you could do any sort of programming language that has a visual output, again, whether it's a website or doing something in Python or something, I would recommend my fellow creators to really explore that. Create a little project. There's tons of tutorials online on how to create some really cool stuff on the web browser using HTML. Or even go to processing.org. That's where you could, this program processing is open source, it's free, you can download it, and there's tons of tutorials online and showing you how to do things. So I highly recommend it. I think it's very important. We learn a bit of technology in our day-to-day lives. This is the digital age, by the way, so it's a better time than any, so let's get on board. Anyway, I am going to get going, and hope you enjoy. Talk to you tomorrow. Bye.